Hello, good afternoon. I'm ready. Okay, I'm gonna try to present as quick as possible this small project we've been working on. We call it the bean counter abacus. Actually, because the counter, it works with binary system. They call it the binary count. Binary abacus. So anyway, it's falling. Okay, the purpose of this project was to try to introduce the concept, the ideas of the coding and the symbols that work with the transistors in the computer, the basics, how the computer inside, the deepest inside, how does it work? How does it present numbers? How does it work to add the numbers, subtract and multiply, do all the math we know how to do? And to begin with, I wanted to show you the different ways that we people have figured out how to create tools to help us calculate. It's hard to calculate inside our brains. It's hard to count. So we created numbering systems, we know that, and then we created tools to help us compute. Way back a long time ago, it was the Chinese abacus and other abaci, plural. The Incas used to have ropes and knots, and they used to do numbers like this. That was the tools. Romans used to have little pegs and play with them and create numbers and then manipulate them to add, subtract, multiply, divide. More recently, in the last century, we started creating pinions and racks and all that, IBM and National Cash Register. A lot of companies grew up by dealing with their own abaci by using spinning wheels and racks with teeth to help it count or uncount, and then repeat it to do multiplication and subtraction, division. So anyway, this is in the past. Today we see that we're putting stuff together in computer chips and then super compressed computer chips. They're called microelectronics. Microelectronics today, we see it everywhere. So to make this work, somebody figured out that we should count by twos instead of by tens. That's where the twos come from. The founder of Qualcomm here was a key player in this movement to change counting from tens to twos. If Mr. Irwin Jacobs was collaborating with other mathematicians and famous around the world, and they created this method by which instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, they say 1 and then 2, go to the next one, then 3 and 4 and 5 and 6 by twos. This abacus that we have here is therefore showing like that, but instead of saying 1, 10, 100, 1,000, 10,000, 100,000, million, and so on, it goes 1, 2, 4, 8, 16, 32, 64, 128. Some of you are familiar with this already, especially if you work on the area of information technology, you get involved with this. So the point here is to try to get the children, the young children, K through 3, elementary school children, familiar with counting by twos, and not just counting, but writing numbers and then adding them, subtracting them, multiplying, dividing. It's very similar to what they do with pencil and paper. Very similar, but simpler, easier, faster. And they enjoy it. We try that, and it works. So by using this abacus, we can start getting the kids aware and involved in the new math that is running the world today. So that's the background behind this project. Let's see. There you go. So with this abacus, you get your number here, and the other number there, they call them registers. You put the two numbers together, and then you start operating them like an abacus, and you get the answer in one of the two registers. For example, if you want a number 9, you go an 8 and a 1. That's 9. You don't have to go to put 9 beans on a decimal. Decimal is base 10 because we used 10 fingers in the old days. Now binary, this is a transistor inside the computer that does this and this. Each one is a transistor. It's actually another little circuit called a flip-flop, but they took care of this and operates at the speed of light. This is today technology, and this abacus, which I have a sample of here. And then in our booth, we have the parts. So anybody that comes around, we'll give them a kit to put together an abacus, and they can play and then have their own little computer. It's got 12 place values, which is 12 bits, they call it in computer is. So this is a 12-bit binary computer for free. We're towards the end on this side, but anybody that comes to our booth, we'll explain some more, and we'll teach you how to use the abacus. We don't need to because we know that computers do it very cheap and fast, and they're all over the place. So, but hopefully the children will get interested, involved, and not afraid of dealing with the guts of the computer. This is it. We can make magic with this simple stuff. This and a little more, and there's more exciting things happening with sensors and activators and all that, and then you can come out with the robots and all the exciting technology that you see around here. All of those things that you see around here, they're working like this with bits, one at a time, in the binary number system. So if you come to our booth, we'll let you have one of those, and we'll show you how it's made and how it works. I was going to show you parts of it. This PowerPoint explains how it works also. So I think I'm out of time. But just inviting you, so if you are curious and if you want to get one of those kits to make your own little abacus, your binary computer, just come and visit us. We're at the end of this row, so, it's got the projection screen, and we got things going there for you. So we'll be glad to have you take home one of those computers. Okay? I'm sorry? No, it's fine. I don't want to bore you because, the details and the excitement, and there's more tools over at the booth that you can come over and see and watch. And hopefully your kids will be excited about it. So anyway, that's the binary abacus. That's how you add.